Last class, we did discuss about randomization and then if-else condition constraints, and then different types of constraints we have explained, like inside constraint, implication constraint, and then distribution constraint, and solve before constraint, soft constraint. Okay, so all these things. Now, implication operator. So how if-else conditions are working, right? Same way, implication operator also working. Okay. So when we are using this implication operator, actually, uh, while coming to the class, uh, suppose you need to complete these things, then only I will take the next class. Okay. So just I'm giving some conditions. I'm putting some conditions, right? So if you complete this one, then only I will go further classes. Otherwise, I can't go. Okay. Same way, here also he is explaining that suppose if you finish your homework, then you can have the eligibility to watch TV. Okay. So parents are restricting children to do the work, right? So suppose if you get good marks in your 10th class, okay, they'll buy a cycle. So how they are giving some offers, right? Same way, implication operator also working like this. Okay, that means the before condition is true only, then only the next condition will be getting. Otherwise, the before condition is not true, the next condition is also not getting true. Okay, same thing, different condition and then constraint. So this is the condition defines that. What is the condition? Suppose if the A address is greater than 100, then only will get the data equal to 10. I am putting some condition. My address is greater than 100, then only my data value should be equal to 10. Otherwise, I can't get the data value 100. Below the 100 value of address, I don't get any data value. Okay. So same way, if else condition also doing like this, right? If condition is true, the true condition will be displayed. Otherwise, alternate path will be executed. Same way here also. So if the condition is true, then the constraint must be satisfied. Okay. If condition is false, then constraint must be ignored. Okay. So the left side part is true only. This is the true. Then only constraint will be executed. This is my constraint. Understood, right? Based on the condition only, the constraint will be executed. Hmm. See here, expression I am saying that and some constraint. Suppose your scale should be low. Then suppose I am taking enum constant, enum data type. In that I am having low, high, and mid. This is my scale range. I am giving the handle is scale. Okay. If I make the scale value should be low, then only my data value should be in the less than 50. Okay. I will get the address value should be less than 50. Otherwise, another values I will be getting at the output side. Okay. So that is the constraint implication operator. Okay. So when we are using means, suppose I want to switch on my TV. Okay, for that power button should be pressed. Then only the TV will be on, right? Or my circuit will be on. When the circuit will be on, a combination circuit is depends upon the availability. Okay, Whenever the enable pin should be 1, then only the value should be present, right? So at that condition, I will take this implication operator. See, if enable pin is 1, if enable equal to 1, then data must be greater than 100. Okay, so that means your enable should be 1 only. You will get the data value greater than 100. That means I will get the output like this. Enable equal to 1 and data should be equal to 101, or enable equal to 1, data should be equal to some 201. In this way, the value should be coming, right? That is the condition. And then if enable equal to 0, and your data must be less than 100. Okay, so that means 55 or some 23 or any number will get. Okay, condition will be false. Okay, sorry, not fail. So that's what. So implication operator, if enable is 1, then only this condition, this constraints will be satisfied. Otherwise, the constraint will not be satisfied. You know this module, right? How to write the module. Just write that module name, class name, and handle, initial begin, object creation, and then randomization, display. How many times you want to repeat it? So use that repeat keyword. That many times your values will be randomized. Okay. Clear? Same equivalent to if else condition. So enable pen is 1, then only the data should be greater than 100, right? Same thing here also, if enable is 1, your data is greater than 100. Else condition, what is that output we are getting? Data less than 100, maybe. Okay, that is the correct, right? So true value is greater than 100. False value is less than 100. Okay, so that's what we are checking. So when should we use if condition? That means better readability purpose we are using the if else condition. Implication operator also is doing like a if else condition, but we don't know how it is working. But if else condition we know every time. So every time we are seeing the if else condition in all languages. Okay. So that is the reason if else conditions we are using compared to that implication operator. Okay. So this is the compact form, that means simplified form. There is no alternate condition. Else condition is not written here. But if condition you don't write the else condition means sometimes the randomization may be failing. Okay. If you write the else condition means the randomization will not be failure. And then what are the condition we are giving? Same condition we are getting. Okay. I told you no. Enum condition. Scale I have considered low, high, and mid like this. Okay. So my scale value should be low or high, then only I will get the next condition. Okay. Same thing here also I mentioned. So low or high, okay, the handle is scale T. Here type def is enum I'm considering. That is the reason I'm considering another handle that is scale. Okay. If scale value should be equal to low, then only if your value should be less than 50. Same way, how we can write the if else conditions? If scale value scale equal to low, okay. So what is the condition we are getting here? Value should be less than 50. Okay. If else if scale value equal to medium. Okay, the uh, value should be equal to 50. Okay, I'm giving the some condition 50, and else condition scale uh, scale equal to high, the value should be greater than 50. Okay, in this way I'm giving the condition. So these many statements I need to write. Instead of that, some compact statement I'm writing, that is the implication operator. Okay, see, same condition is also written, and then implemented different values. Okay, so low, medium, high. If you are having the low value, okay, value should be less than 50. Mid value should be 50 to 100, and then high value should be greater than 100. Then I'm considering constraint scale equal to low, implication operator value should be less than 50. And another condition scale equal to mid, and then value should be range, right? 50 to 100. Then I'm using the inside keyword. Inside keyword is the uh, inside keyword is used to generate range values. Between some range values, okay, we will use this inside operator. And then what else? Other conditions scale equal to high. Okay, so then value greater than 100. Same way I have considered the else condition also. First condition if scale equal to low, value should be greater than less than 50. And else if scale equal to medium, okay, value should be inside in the range of, so value should be inside in the range of 50 to 100. Okay. Else condition, what is the other condition? Scale equal to high, the value greater than 100. Clear? How I am writing conditions. So these are the simple examples for implication operator. But real-time usage means whenever my address is greater than 100, then only data value should be present. Or sometimes I want to equate that address value. Some addresses are not hitting. Okay, at that time I am writing these constraints. Okay, so then that address is changing, my data value should be obviously hitting that. Then only I will improve my coverage. Okay, so that's what same thing implication operator inside this. So implication operator inside within the inside keyword. Inside keyword I told you the range values we can generate. Okay, so range values will be generated. Okay, so in between the 1 to 10 values we will get that. Okay, so then same thing I have implemented this code. Just so someone ask you to write the code as constraint. Just write the logic only, because everyone knows this TB, because TB can't be changed, right? Module TB, and then class name, handle, initial begin, object creation, after that randomization, display. That is common. So have you observed that all constraints are following the same TB? This constraint is changing. Same way, multiple conditions. Multiple conditions means one condition is true. Okay, it is depends upon the condition. See, this is the one condition, and if condition is true, then only the mode value will be high. Okay, mode or enable, both are same. So where you are seeing the mode condition, suppose in universal uh, buffer or register. Universal register depends upon the mode. If mode equal to 0, it will be acting like an adder. Mode equal to 1, it is acting like a subtractor. Okay, add and subtractor diagram, both are implemented in the same diagram. It is depends upon the mode. Okay, mode or enable, both are same. So mode equal to write and secure. Okay, you are doing the operations in XA protocol. We are doing secured operations. Secured operation means uh, no one can what is called destroy the data. Okay, we will providing some security encryption, right? Suppose you are operating some banking, online banking. Okay, your account number is added while using your account number and password you are logging, right? So then how you are entering your password? Someone is seeing, right? But the encryption is provided. That means the password, whatever you are entered, that should be converted into some different symbols. Symbols or some other characters, all these things. Then no one will identify your password. They need to decode it. Okay. So decoding is not possible, right? So that is the reason we are giving some secured operations. Okay. If write and secured both are one only, write equal to one and secure equal to one, then only my address is greater than 100. Okay. Otherwise, my address will not be getting greater than 100. Okay. So why I am writing this condition? Sometimes my write operation is not doing well, and my address is not getting 100, greater than 100. So you are giving the address range more than 100, but some addresses are not coming. Why it is not coming? I will write this type of constraints. Then this constraint is hitting means okay, not a problem. Otherwise, not hitting means I need to check where the address is not getting. Okay. So this type of scenarios we will check them. And then implication with address alignment. Aligned address means address should be divisible by 4. Every time the address should be divisible by 4. Okay. Then only my address is aligned address. Okay, I'm checking that. Word access is 1, then only your address will be, the address should be aligned address. Otherwise, we don't get any aligned address. Okay, clear? So aligned address, you know, right? So this is my address. Okay, so 0, 1, 2, 3. Okay, 4 locations. Again, another 4 locations. Okay, so 4, 5, 6, 7. In this way, the address will be allocated. Each value 8 bits, right? Total 32 bits. Okay, that is the reason every address should be aligned, that should be divisible by 4. Okay. Same thing in AXA verification, burst types of fixed burst, increment burst, traffic. Okay. So I'm checking them. My address should be burst type should be traffic. Then my address length. Okay. So length inside 4, 2, 4, 8, 16. In this way, I will get the length. You know how to calculate the burst calculation. They will give you X length. Okay. And then size. Size and length they will give you. Based on that, you need to calculate that. And also start address also they will give you. You need to calculate that wrapping boundary. Okay. So here wrapping address calculation they have given, right? So upper boundary and lower boundary you need to calculate it. Based on that, is that crossing the boundary or not crossing the boundary? We'll check that. Okay. CPU verification also same thing. Addition, subtraction, multiplication, division. Okay, so you are doing some different operations like addition, subtraction, multiplication, or division. Okay, so you want to give some constant values. Your output should be division. Then uh, source should not be equal to 0. Source 2 should not be equal to 0. Okay, so he is saying that address is divisible. That means you are doing some division operation. Then I am taking two types of sources, source 1 and source 2. Your source should not be equal to 0. That means any number I need to consider that. Okay. And then source 1 also I need to consider any type of other number. Based on that only the constraint will be satisfied. Otherwise it's not satisfied. Same multiple conditions like address and data. If write and secure both are equal, both are 1, then only address should be greater than 1000. Or if write is not equal, then only uh, data should be equal to 0. Okay. Not writing means reading, right? Then data I am not giving anything. I am getting the data. That is the reason that my data should be equal to 0 and 10. Okay. This is UVM example, don't go for this. Okay, I will explain. In sequence item only we are writing the constraints. Okay, just read this one. See, class sequence item type the phenum is considered two values, low and high. Handle is scale underscore t. Okay, and then rand scale underscore t scale is considered as handle is scale. Okay, and then value I'm considering that is 8-bit value. So how many values it will store here? Up to 256, 0 to 255. Okay, then I'm writing the constraint here, scale equal to low. Okay, so value should less than 50, or scale equal to high, value greater than 50. Two conditions are considered in class. And then module common, right? Module TB sequence items SQ, handle is SQ, initial begin, object creation, and repeat 10 times, randomizing and displaying the values. Okay, SQ dot scale and SQ dot value. Okay, sometimes REQ also we will consider. Okay, and RHS also we will consider. Handle any type of handle we can represent, right? Use a defined name. Just save and run this one. Just see scale equal to low, the value should be less than 50, right? Scale equal to low means value should be less than 50. Okay, low means 0. Okay, and then scale equal to high means uh, that means 1. Okay, so one condition, the value should be greater than 50. Okay, so only two values we got, low values, remaining all are high. Depends upon the simulator. If you want to repeat 100 times, then your low values are also getting somewhat higher values. Okay, yeah, only 10 values means we are repeating 10 times. Repeating 10 times. We are repeating 10 times. So then randomizing 10 times only we are getting. Suppose you are giving 100 means then 100 randomized values we will get. See, understood, right? Same way, another example also. Uh, three conditions I am considering. Sequence item, low, medium, high. Value also same. Greater than less than 50 and scale equal to mid 50 to 100. Okay. And then scale equal to high greater than 100. Okay. So then same TB. TB is not changing. Right. Then execute it. What is the conditions you are considering? Low means less than 50 values I need to get that. Check any low condition. See, zero condition. Okay, zero condition means low, right? Okay, so 43 I got that. And then mid means one. One condition, the range should be 50 to 100. 93 I got it. Okay, here also 52 I got it. So then values are satisfied. And then scale equal to high means greater than 100. See, high value we are getting too many values. Clear? Implication operator. For each loop, you know already I think for each loop. What is the use of for each loop we are using? You want to for each loop. You are considering any array. In your array values, I want to visit all the elements in my array automatically. So then I will use the for each list. Okay, understood, right? So that means imagine you are a teacher checking out 100 students without loop. Without I'm using loop means student of 0 greater than 35. So each and every person I need to check that. Otherwise, I will take that for each loop means for each student of 5, then student of 5 greater than or equal to 35. Then each and every value is considered. How much the array size you consider, based on that, those many values will be repeated. Okay. So why do we need for each in constraints? That means you are writing some constraints, right? So sometimes you will consider dynamic or different type of arrays. I want to visit each and every value in my array. Then I will take the for each loop. Okay. So that's what. Without for each loop, date of 0, date of 1, date of 2, date of 3, we need to mention individually. If you consider the for each loops, it will visit automatically. That's what. Um, so any constraint like this. Suppose constraint name for each array of 5 expression you are considering. So that means for a of I, suppose rand int a of dynamic array I am considering. Okay. So dynamic array, what is the inbuilt method? What are the inbuilt methods of dynamic array?
First to last.
Size, resize, delete. Okay. Same way I will. So constraint you can take that C1 and then a dot size equal to some 10. That means your size should be 10. Your dynamic size array should be 10. Okay, in this way I will assign some size. Okay, a dot size equal to 10. After that, each and every element I need to visit, right? Then for each a of I, I will consider that. Okay, so then you can write the constraint. In this way, you will write the constraint for using for each. And two-dimensional also we can write, right? For each area of I comma z. Okay, I comma z we can write that. Same thing. So just I'm explaining the dynamic array, right? Basic dynamic array constraint. Array size should be 5 and element should be greater than 0. Okay. So then how I can write that? Data dot size equal to 5. That means data is my dynamic array. Then dot size equal to 5. That means size equal to 5. Your array size should be 5. How we are assigning the size in dynamic array? A equal to new of 5. Something we are assigning, right? New of size we are assigning. Okay. So A equal to new of 5. In this way, I can assign the size. And how resizing it? Same way, A equal to new of 10 and then bold array. Okay. So in this way, we are resizing the dynamic array. Same way, here also I can mention the size. Okay. So A dot size equal to 5. So size is the inbuilt method in the dynamic array. Okay. And then for each data of I, each and every element I will consider because I am taking the randomized data. Integer means 2 power 32 values it will come. But size you mentioned 5 only, right? Only 5 values will get that. Okay. So data of I greater than 0. Condition is mentioned that elements greater than 0. Data of I greater than 0. End class. Module DB, you know, all the things are same. So just class name, construct, object creation, and then randomizing. After that, we call this display method. Okay. So each and every time I need to consider the for each packet of data file. That means I want to call each and every element in my data. Okay. That is the reason for each data file I will consider. And then some range restrictions. Okay, you are getting some size, you are mentioning some size, array size. And similarly, I don't want to get all the values. I want to get in between the some range. Okay. So at that time we can also assign some range values. How we can assign the range? Inside keyword we can use. So inside operator, data of I inside 10 to 20. So he's mentioned that every element must be in between 10 to 20. Whenever they are asked to write some constraint to generate some range values, you need to consider inside keyword. Okay? Inside keyword will gives you that range values. So 10 to 20 only I will get the values. And then index values. Index values means so requirement each element must be greater than its index. That means 0 index you are considering. Data should be 1 or 2 or 10. That should be greater than index value. Index value 10 you are considering. Your data should be 25 or 12, any value. So that is the reason data of I greater than I am considering. Okay. So data of I means your data value, and then I is the index value. Okay. Square relation. Square relation means I into I. 0 into 0, 0 square. 1 into 1, 1 square. 2 into 2, 2 square. In this way, every element should be square of that one. Okay. That means 1 square you are considering. Then data should be greater than 1. 2 square you are considering. Data should be greater than 2. Okay. 4. Even numbers only. How to get the even number? The number should be divisible by 2 means you are getting even numbers. Okay. Same thing. Whatever the data I am considering, percentile by 2 equal to 0 means then I am getting the even number. Why I am considering percentile? Because it calculates the remainder. Remainder is 0 means even number. Remainder is other value means odd number I will get that. Okay. Same thing. Data dynamic array size equal to 8 for each data of I. Okay. Before applying the condition, you need to write the for each condition. Okay. Unique array. Unique array, unique data means unique keyword is there, right? So you can write the unique one. So whatever the dynamic array I am considering, each and every time unique data I will get that. Okay. So increasing order. How to get the increasing order? Data of I greater than data of I minus 1. Okay. So this is the increasing order condition. So that means array of 0 you are considering. 0 is greater than or equal to. So here 1 is there. Then I need to consider from 1, index 1. Because 0 is considered means negative value will negative value will not be considered here. Okay, greater than 0. That means 1 I will consider. From starting from 1 and then 1 minus 1 0, then a of 1 greater than a of 0. Okay, so it will check that some 1 2 5, okay, 3 4. In this way the values will be there, array values will be there. I want to represent in ascending order. Ascending order means how to write that ascending order? 1 comma 2 comma 3 comma 4 comma 5. In this way I need to get that answer. Okay. It will check each and every value. A of I greater than A of 0. Sorry. A of 1 greater than A of 0. This is 0th position, first position, second, third and fourth position. Check that condition. So A of 0 is 3. 3 is greater than 1. Condition true or false? So 3 is greater than, condition is true. Okay. So 3 is bigger value compared to 1. Okay, it is keeping same. Again, check the another condition. Okay. So in this way, increasing order will be assigned. Okay. So decreasing order you want to write means same thing. Data of I less than data of I minus 1. Okay. This is the decreasing order. So these are the basic questions they will ask you. Can you write the array of ascending order? So can you write the constraint order? Just take any dynamic array. So mention size. Okay, data dot size equals some 10. Write the for each condition for each, and then constant you can write that. Okay, data of 5 greater than data of 5 minus 1. Okay, so then zeroth position and then first position, so it will consider that. Okay, so here what is the condition? I'm checking area of 1. Area of 1 is 1, right? 1 greater than 3. Condition true or false? So condition false. Then it will swapping that. Okay, so zeroth position should be 1, 1 position should be 0. Then 1 comma 3 it will print that. Then again another condition it is checking. Okay, so in this way the value should be changed. Okay, so descending order also same thing. And then see, this type of question is asking many times. Can you write the uh, even numbers in odd locations, odd numbers in even locations? Even location means what? This is the location, right? Zeroth index, this is the location. 0, 1, 2, 3, 4, 5, 6. These are the locations, right? What are the even locations? This is even, right? This is also even. This is also even. And this is also even. In this even position, you want to write that odd values like 1 or 3 and then 7 or 9, okay, and then 13. In this way I want to write the values, okay, and then these are the odd locations, right? Okay, so in these odd locations I want to write the even numbers like 2, 4, 6. These values I want to write there. Okay, so then you want to divide the index also. If I percentile by 2 equal to 0, then even indexes I will get that. Then what is the values I want to write here? Odd values I need to write. Okay. So here I am writing even values location. So odd index, even values, even index, even values, odd index, odd values. Okay. He's writing the correct one. Okay. So just whatever I am explaining this one. For this I want to write this condition like this. If I percentile by 2 equal to 0, data of I percentile by 2 equal to 1. That means even locations I am getting odd values. Else condition. Else condition, data of I less than percentile by 2 equal to 0. That means else condition is odd locations. Odd locations, even numbers I am writing. Understood, right? Or sometimes they will ask you even indexes, even values I want to write, odd indexes, odd values I want to write. Okay, then same condition I need to write even index, even values. Percentage by 2 equal to 0 means even values I will get. Else condition, odd values I will write. Clear? Any doubt? For each with multi-dimensional array, you know already how to write the multi-dimensional array of I comma j. Okay, so two-dimensional array I will write that. So same thing here also he is explaining that for each plus implication operator. That means if else condition like that. If I percentile by 2 equal to 0, that is even conditions, my value should be less than 50. Or odd values, my value should be less than greater than 50. So and then packet verification, like your payload should be in between 0 to 255 values. I want to get that. Okay. So for that, I'm writing the some payload value. So what is the payload? Payload means data. Data or payload, we can write that. And constraint payload dot size inside. Size also we are mentioning inside range. What is the range? 64 to 1500. Okay. So then those many values we will get that. And also for each uh, payload of I, that means each and every value we will consider that. Okay, and inside in the range of 0 to 255. Okay. That is yeah, size. This is size, and this is the values. And then AXI burst data also same thing. So 64 to 120 will be allowed. 0 to 25. That means your size is 65. Okay. So one condition 65 you can consider means the data value should be 0 to 255. Any values you will get that. And the next condition size should be 66. Okay. Because size is also varying. Previously I mentioned that size equal to some 5, size equal to some 10. In this way I mentioned. But now I am not mentioning the size. My size is varying in between the range 64 to 1500 because I don't know my size when I am reaching the value. That is the reason my size value should be increasing every time, changing. Same thing here also data I'm considering and then burst length. Okay, the length inside between the 1 to 16. In AXI3 the length is 16, right? 4 bit, 2 power 4, 16. And then XL for 8 bit. Okay, 8 bit means 256 values will come. So based on that, that is the reason he's mentioned that 1 to 16 length. Okay, and then data dot size equal to burst length he mentioned. That means size is also varied here, 1 to 16. Sometimes 1 may become, sometimes 10 may become, or 15 may come. Between 1 to 16, right? Any value will be assigned. And then your address should be inside in the range of 32 bit. Starts from 0 and ends with all else. Just read this summary. For each some AXA transaction and considering. Okay, rand bit 31 down to 0, dynamic error and consider. Rand int burst length. Then constraint burst C. So constraint name is burst constraint. Okay, just C means constraint. Okay, burst length inside 1 to 16. Okay, length should be 1 to 16. And data size is equals to burst length. Whatever the size you are considering, suppose burst length is 60, then size is also 60. Or burst length is 4, then size is also 4. Okay, for each data of I, okay, so inside in the range of 0 to all effect. Okay, end class. So module DB. So what is your class name? AXI transaction, and then AXI handle, initial begin, AXI handle equal to new, repeat of 10, randomizing, and displaying them. Data equal to percentage 0p, length equal to percentage 0p. Okay, AXI handle dot data and burst length. Okay, run this one. See, the length is 5, burst length is 5, and also I'm getting data are 5. Okay, data range is also 5. Length is 9, burst length is 9, and you are getting data also 1, 2, 3, 4, 5, 6, 7, 8, 9. Length equal to 1, then data is also 1. Understood, right? The data should be inside the range of 0 to etc. Okay, 32 bit, right? So that is the reason 32 bit value I'm getting here. So distributional constraint. What is meant by distributional constraint? What is the use of that? You are randomizing the different values, right? You are randomizing and then you are getting some different values. Every time some repeated values will get, right? By using randomization. But I don't know. I want to repeat one 5 times, or two 10 times, or three 2 times. I want to restrict that randomization repetition values because during randomization the number may be repeated any number of times. Have you seen that? Now only we have executed scale high. That high will be repeated more times compared to low. Okay, compared to medium. But I want low values more compared to high, compared to medium. Okay, so for that purpose, I'm using this distributional constraint. Okay, so why we are using this? So the equal probability is not getting right in randomization. Okay, so one of the biggest misconceptions in randomization is random does not mean equal probability. Right? Randomly I'm picking them. So is there any equal probability I want to pick him twice or I want to pick him thrice? No, right? Randomly you will get right. So you know in the intermediate time base theorem is there. We are picking the ball, red color ball, green color ball. Randomly we are taking the ball. So just you are taking the ball, green color. Again next time also you will get green color. No, right? Red color will come. Or sometimes again green color will come. Okay. So that is the simulated decision, not our decision. Same way, the distributional constraint is giving some priority. Okay, so then see how is preparing that. Suppose 100 marks question we are preparing the. So I want to put an exam. Then I'm creating the question paper. So in that 100 marks question I'm preparing that. So in that easy questions 70%. Easy questions 70% I'm making that. And medium 20%. Hard 10%. Okay. I need to think about all the students. Okay. Based on that, I will prepare the question paper. Okay. Otherwise, everyone will fail. Same thing, the distributional constraint is also working like this. This is exactly what dist keyword does. It allows us to control the probability of generated random variables. Okay, we don't have any controllability on generating the random values, right? But constraints are controlling that. But still, those are also restricting some range only. Okay, based on the range, we are getting some values. But I want to get some value. Suppose I want him only repeat thrice times, 3 times, and her only I want to repeat 5 times. Okay, but it is not possible in randomization. But distribution constraint will do that. Okay, so the keyword is dist. Keyword stands for distribution constraint. It controls the probability, weight, frequency, occurrence date of random variables. Random values we are getting, right? Those values we will control it. Okay. How we will control it? Two keywords are there, two operators are there. Okay. So column equal to one thing and column divided by is the another thing. Okay. So column equal to see 0 is the low value is giving 80%. That means 0 will be produced 80%. So how many times you are repeating? 10 times. In that 10 times, 8 zeros I need to get there. Okay. 2 only I need to give 1. Okay. So based on the percentage is mentioned. Okay. So that 0 occurs more often than 1. That is true, right? So column equal to 1 should be equal to what is that value? 20 times it will repeat that. And 0 value should be repeat 80 times. Here two operators I told you, no? So suppose I'm giving some range. Okay. So 2 should be repeated. So 100 to 200 range I'm giving. Okay. This is equals to some 100 times. Okay. So then 0 100 to 200 values, how many times it will repeat? Each and every value 100 times I want to repeat it. That means 100 should be repeat 100 times. 200 repeat. You should be repeated 200 times. All these things. Okay. But column divided by is there, no? 100 to 200 same range. Column divided by 100 times and mention that. What is the range values here? 100, right? And then what is the repetition range? 100. 100 by 100 cancel each other. Each and every value should be repeated one time only. Okay. So column equal to repeats. What is the range we mentioned? Okay. How many times you want to repeat it? All the values will be repeating those many times. Whatever the repetition value you mentioned. Okay. That is column equal to. Column divided by whatever the range you mentioned, that range values how many count is there. Suppose 10 to 0 to 1000 is there. That means 1000 numbers are there. And you are repeating 2000 times. Okay, 2000 divided by 1000. What is the value? 2. Okay, so that means 0 to 1000 values will be 0 will be repeated 2 times, 1 will be repeated 2 times, 2 will be repeated 2 times. Okay, in this way, the 1000 values will be repeated 2 times only. But colon equal to 1000 times it will repeat. 0 also repeat 1000 times, 1 also repeat 1000 times, 2 also repeat 1000 times. Okay, so that's what. So uh, here variable dist. Okay, item 1 is colon equal to weight 1 times, weight 2 times. This is the basic syntax of your distribution constraint. Okay, single value mentioned. Okay, those many times it will repeat that. Okay, so then constraint you mentioned. Class packet constraint 0 is repeated 80 times and 1 is repeated 20 times. Okay, so the weight I mentioned here. So colon divided two operators I told you, colon equal to colon divided by. Colon equal to, so assign full weight to each and every value. I told you no. So here 5 to 8 values I want to repeat it. How many times? 7 times. Okay. So then 5 will be repeated 7 times, 6 will be repeated 7 times, 7 will be repeated 7 times, each and every value will be repeated, those many weight you have assigned, right? Okay, whatever the weight you have assigned, those many times the value will be repeated. Okay, that is column equal to. Clear? That means 5, 5, 5, 5, 5. So 5, 5. So 5 will be repeated 7 times. And also 6, 6, 6, 6. Okay. So this will be repeated 7 times. Clear? Example. So this is also same thing. And colon divided by how many times here? 5 to 8. 5, 6, 7, 8. Okay. 5, 6, 7, 8. 4 values are there. How many times are repeating? 8 times. So 8 divided by 4, that means 2. That means 5 will be repeated 2 times, 6 will be repeated 2 times, 7 will be repeated 2 times, 8 will be repeated 2 times. Okay? That means we are giving some priority. I want some number should be repeated more number of times compared to the other number. So at that time, this distribution keyword will be worked here. Okay. Mhm. Huh. Second example, a range is not there means no problem. So here difference between the values colon equal to and colon equal to. So single value you mentioned means those many times it will be repeated. So range values only it is different. Okay. Suppose colon equal to
Here the 3 will be repeated 4 times.
which one? 3 will be repeated 4 times.
4 times. Here
Again,
8 will be divided. 8 divided
7 times it
4.
will be.
7 divided.
Again,
It's in a decimal. 7 divided by 3.
decimal also it is approximately integer value it will consider. Suppose 1.5 times means approximately 2 times. Approximate value is 1. Okay, it will take approximate value
2 or
2. Okay. or it will take one only. Depends upon the
Greater
simulation.
than 1.5.
So column equal to 4 is mentioned. Okay, 2 will be repeated 4 times. Same way, column 2 will be repeated 4 times. This is also same. Column divided by single value mentioned means same times it will be repeated. Because only one value, 1 divided by 4, 4 times only it will repeat. No difference. But range values, it will differ. Okay, so that's what. See, 70% low values will be repeated and mid values will be 20%, high value will be repeated 10%. Okay, so then I'm writing the constraint of level distribution like 70, 20, 10. Okay, so in this way I will mention that. Same thing, I want to generate the address. Address should be 0 to SF. Okay, so then this address I want to repeat more. Then I'm giving the highest percent. So FF is there, right? All ones. Plus one add you can means next address will get that 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. So 1 0 0 0 is the next address and ends with all F's. Okay, that would be repeated 20 times. And you need to remember, uh, compared to that value, that weight should be more. Okay, whatever the value you are assigning that, the value should be less. Okay, 2 is that, and then weight should be mentioned more. Okay, and then so 20, and then weight should be 2 times means it is somewhat upward it is feeling that. So most of the times we need to represent the weight should be higher compared to the value. Okay. So same thing, burst length. Length 1 10 times, 2 10 times, 4 20 times, 8 30 times, 60 30 times. Okay. So different
Here the range is from each to 5, which is 80%, right? In
uh, 80%.
so then, like
So
1, 2, 4, 5, it will repeat 80 times.
not 80% is mentioned. Percentage means, so most probable case we are giving um, so, uh,
Like if
80%.
we assign like this, it will repeat 10 times.
Huh,
That is 80%.
80%. So percentage we are mentioning here. So because here I am giving some modes. Okay, some other type of freedom I am considering. Okay, in that fast mode, low mode, and then ultra fast mode, I am mentioning some conditions. So zeroth value will be repeated 80 times, one value repeated 20 times, and then two value will be repeated 2 times, so 30%. So percentage I will mention that. Okay. In fast mode, short delays appear more. Okay. That is the delays is the short delays. That is the representation 80% I mentioned that. And longer delays will appear less. Okay. Similarly, implication operator I am also implementing. So my mode should be low and value should be distribution in the range of 0 to 50, 90%, 51 to 100, 10%. That means these values only repeated more times, 9 times, and these values will be repeated 1 time for each condition also. So payload of I, okay, each and every value will be repeated at different values time. So this is UVM example. Okay, so read this summary. See this example. Two values I am considering, value 1 and value 2. Okay. So value 1 is in the range of 3 will be repeated 4 times and 5 to 8, 4 values are there. See, 7 by 4 means 1.78 something. Okay. Uh, so then constraint, another constraint, same thing. I'm mentioning that colon equal to, okay, colon equal to 7 times. So how many times you are repeating? 20 times. Okay, just run this one. In this 20 times, value 1 and value 2 will be adjusting. Okay, so those many values will be repeating. So 3 will be repeated 4 times I will. Okay, 1, 2, 3, 4. Okay, more number of times will be repeated because I'm giving 20 times repetition, right? Suppose 10 times I'm giving means here 5 to 8. How many values are there? 4 values. Each value should be repeated 7 times. I need to repeat. Okay, and here hmm, so here also 3 will be repeated 4 times. Then here also 3 value will be there. Okay, and then here 5 to 8 values. So those many times it will be repeated. Clear? We want to comment one constraint, you can comment it and then see the another value. Which one I have commented? Value 1, right? Okay. See, so each value 3 will be repeated 4 times. I'm giving that most prior and then 5 to 8. So 5 to 8 value, how many times it is repeating? 7 times. Each value should be 7 times I need to repeat that. But how many times it is repeated? 1, 2, 3, 4, 5, 6, 6 times I got it. If you want to repeat more times, then you will get more values also. 200 times I am repeating. Then 5 will be repeated more times. 7 also getting. So 2 times, 4 times, and then 6 times, 7 times. simulator will take that. Okay,